Hello everybody. Okay, this is a audio amplifier that will work on 28 volt. It's push-pull. The tubes are, let me get this around here. The tubes are similar to 6V6s. And there's a lot of room for experimentation here. 6V6s might work. 6W6, a 6K6. And it's quite possible that even like a 6BQ5 or something might work in here. This is a push-pull circuit. And this schematic is right out of the R392 manual, page 82. And page 81 has the preamp. And all I've done is taken those two schematics, connected them together in my little paint program to where it's all one schematic. But I've left all of the part identifier numbers the same, so as you refer back to the manual, you can see what the original part numbers were, and then how I've eliminated a lot of like extra connections to a squelch relay, different things that weren't needed because it just caused confusion. Cleaned all that up. I'm using a 70 volt to line transformer for speakers. It's a little line to matching. It's got a 8 ohm and a 4 ohm output. And I'm tied off of the 4 ohm to my 4 ohm speaker, and the 8 ohm goes back through the feedback resistor back to the input circuit, just like the original circuit shows. Only you have to go to a different page to see what's going on there, because they've split these up, like I say, on two different pages. So there's my schematic, and I've used a pair of 6DT6s as the audio preamp and phase inverter. I started out with some 6AK6s. It was a little distorted. Didn't really sound good. I haven't tried other tubes, but there's some room for experimentation there too. You could try a 6AU6 or 6BA6, 6AH. I mean, there's a lot of different 7-pin tubes that you could, as long as you hook up the pins accordingly, you could experiment. I've left the schematic drawn as original. This was originally one tube inside of, and there was two tubes inside of one envelope. So it's your circle here, this is what this means. And to avoid some confusion on what this was, I just simply numbered them according to what the pins would be on the, let me get it here, get the right schematic. Okay, numbered them according to what the pins would be on a 6888. That's the tube I used. Now, as strange as it sounds, this tube was originally designed for the early computers. It says right on the data sheet that it was a dual control computer pentode. And that's kind of, I got a chuckle out of that. But yeah, computers at one time did use tubes. The structure of the tube internally is very close to a 6V6, which, like I say, I didn't have two of them, so I didn't try it. That might be something you could try. It seems to do pretty good, a fair amount of audio. It's not extremely loud, and like I say, we're only running on 28 volts. The original circuit in the R392 was only meant to run headphones. So the fact that it runs a speaker, I think, is pretty good. We're getting probably a watt, or maybe a half a watt, watt and a half, something like that. It doesn't sound that bad. There's a little room for improvement, but like I say, just a little bit of experimenting, and I got it to sound fairly decent. Now I'll hook it up here and show you. This is the filament lead, so we'll hook that up first. You can see it dim my lights. I've got everything running here on 12 volt. And when that warms up, okay, I'll hook up the 28 volts. Okay, that's running. And I've got a little MP3 player that gives me my my source of input. This is just a matching transformer that matches the 8 ohm output of the MP3 player back to I think it's 5K impedance input, but that's just a sort of for a source. So, and it's music, so it doesn't sound that bad. It has a fair amount of bass, as you'll see once it gets going here. So there it is, a push-pull audio amp running on 28 volt. Now there hasn't been that many views to this the 28 volt series of videos. So what I'll do is I'll make this my last one on this thread and wait and see if there may be I get some requests for more videos on the subject. If you follow the manual, get a look at it. It shows the complete receiver. There's a lot of complicated parts in it that do not necessarily need to be there. They go clear from a couple mixer stages all the way through to the audio amp. I think even 6 IF stages. But all you would need is probably 2 or 3 of those IF stages. And you could use 455 KC IF transformers out of CB radios, tube type CB radios would work. Like I say, the original circuits are there. The circuit I pulled this from was from page 81 and page 82. Oop, I guess that's not in the video where you can see that. But yeah, page 82 and page 81. And the, like I said, the little driver tube, so the original tube they call for in the receiver is a 6AJ5. And I just substituted a 6DT6, and it seemed to work pretty good. Okay, I will do a little more with the CB radio shortwave receiver series, but I thought this was just an interesting idea and thread that maybe somebody would be interested in running a push-pull audio circuit on 28 volt. I'm actually running this one right directly off of a 230 watt solar panel that is 24 volt. And open line, I can measure about, well, let's see, here it's setting, I'm getting 35 volts. And I think when I had the audio running on here, it pulled it down to about 33 volts. See, we're getting we got a cloudy day today, real cloudy day. So as the clouds change, the voltage will change. But this circuit isn't too critical. It'll run on anything from about 24 to 36, 37 volts. So I just thought, well, it would be fun. I'll just hook that direct to my solar panel. I've got a line coming into my work area here that's directly from one of those solar panels, and just to see what would happen. The filaments I ran on 12 volt. I've got a 12 volt line out to a car battery sitting outside the room. That's why the 6 volt filaments of the two output tubes are in series, and the 2 filaments of the 6DT6s are in series. If you wanted to use a different tube and say, so both of these weren't the same, the one thing I want to call your attention to is make sure the current, the DT6, what'd I do with it? Okay, the DT6 has a 0.3 amp filament, and so some tubes have more, some tubes have like a 0.15 amp. So whatever you use, you would have to be sure that both of these were equal, otherwise one tube would be cooler and the other tube would be getting more filament voltage than it really needed. So that's the only criteria there. If you decide on different tubes, just make sure they're either the same or that their currents match on the filament. Okay, that's it for now. Give you a look at the little line transformer there. It's all pretty simple. Wasn't that many parts, and I wired it just exactly as it was pretty much shown in the manual, the R392 URR military receiver manual. Okay, have a fine one, and I'll catch you on the next video. Okay, I ended that last bit of this video because I was trying to get the video done before the battery died. So, and I realized I didn't leave some final information. The information on the 28 volt receiver is based on a military radio called an R392/URR. You can download the PDF. It is a technical manual named TM 11-858. And when you see the cover of it, it should be dated 29th of June 1954. The information on the theory starts on page 44, chapter 4, and it'll give a full explanation of each stage, even what down to the parts, the capacitors, the resistors, your major components. It'll give that explanation of what and how the receiver operates. And from there you should be able to get some ideas where you want to head off to try to build a shortwave receiver. You don't have to use the complicated coils that they use, just a standard 455 kCIF, and that'll become evident as you look through. The complicated coils that I've explained in the last videos, they're because the radio is designed to have a narrow, medium, or wide pass band. It just means it can narrow it up for like CW or other things. And you would want probably medium, but your standard IF transformers from a CB radio, a tube type CB radio, will give you a reasonable match from anything from the broadcast band, even sideband will go through it just fine. And if you need more information, if you want to try to tackle building some of these circuits, experiment with them one by one, I'm willing to give a one-on-one type help if you just send me an email and I'll work with you. There doesn't seem to be enough viewers, as I've mentioned earlier, so I'll leave this series, will it run on 28 volts? I'll let it end here until I see if there's a good request for more information on it. And like I say, I'm fully willing to help somebody. Send me an email. I'll send you the schematics that I've redrawn. They're in JPEG, small format. They're only maybe 100, 200K, even less than that. And I can guide you on building some of the stuff. And there's lots of room for experimentation. Different tubes you can try. It's just a matter of hooking the tubes up. Even though the pin numbers are different, just make sure that the screen, grid, control, and the cathode and the plate are all as the schematics show. And you shouldn't have any trouble getting it to work. Okay, with that, thank you for watching. And we'll try to pick up where we left off after the Q meter, and we'll try to start building. The next thing should be a RF amp that'll run on 100, I think it's 150 volts. This is the standard voltage, and that'll be the input stage of the shortwave receiver. Thank you. Until then.